Oh, we're live. Hello, everyone. How is everyone doing today? Oh, I do not see chat messages rolling in. Type your
Really?
messages to chat relay so they pop up on screen, pop up to us as well. Um, yeah. And as everyone's rolling in, I got a quick question for everyone. What grade are you in, and what state are you from? Just so we get a feel for like who's in the room.
Oh, I still don't see any messages.
I don't either.
It's unfortunate. Am I on the right thing? No, I'm pretty sure it's I'm pretty sure we used the right chat relay. So.
Oh, let me go in 1 second.
All right, to get your message to
Oh,
pop up on the screen, you want to set it to chat relay.
okay. There are three people watching right now, so maybe they just didn't send messages, which is
Okay.
fine. But if you're watching and you want to tell us what grade you're in, that'd be fun. Um, I just like to know. It's always curious because sometimes we have like third graders in here, and then other times we have eighth graders. It's always interesting.
Hmm.
Also,
Yeah,
I'm
this is
realizing,
the fifth and sixth grade. So,
yeah, but I'm sure it'll be interesting even if you're in eighth grade, seventh grade, whatever.
what do we still have no? Still no messages? Come on, guys.
Um,
What if they're just sending messages and we can't see them?
that'd be quite unfortunate.
Yeah, that would be unfortunate. Oh, wait, no, we got a message. We got a message. And it's an answer to the question,
It's
not
C.
what grade
Okay,
they're from.
wait, you should probably take the we should probably take the questions off the screen.
Yeah, yeah,
Um,
yeah. All right.
that's funny.
Instead of
Okay, at
focusing
least
on the math right now, how about we first what grade are you guys from? That's the question you should be answering.
okay, at least we know you can send us messages, which is good.
Yeah.
Um,
Can they hear us then?
yeah, they can.
Oh, five. Yeah, yeah, five and six. Wait, you're in two grades. Wait, what
Five
does
and
that
six.
mean?
That's interesting. Five
Okay,
and six.
okay, okay, just six. Sixth grade. That's better than being in like grade 5.5 or like
Yeah. For everyone
and
here,
which state, right?
we're just gonna wait for like 2 minutes to let people roll in, before we get started. So yeah, Nala. Interesting. Was an interesting name.
Okay, so at least it got like one sixth grader.
Good. Yeah, I see people sending DMs to the Zoom person. Don't send DMs to there. Send them to chat relay so they pop up here on screen, and then we can respond to them, and then we can chat. We can have a conversation, which is always nice. If you have any questions
Mhm.
during the live solve or anything, we can answer them. But if you send them to the Zoom like presenter, we won't be able to see them, which is unfortunate. My name's Buddy Love, and I'm using my mom's Zoom. That is a cool name. That's cool. I like that name.
Oh, there's another
Um,
response. Isha,
Isha. My
sixth
name's
grader
Isha. I'm
from
a sixth grader
Texas.
from Texas.
I'm assuming you guys took the test, right?
Did you? Did you guys take the test? I haven't taken the test yet. I don't know what's on it.
Me
We'll see.
neither. I mean, like, I probably didn't take the test. It's probably because I'm not in fifth or sixth grade, but
I think I took Math Kangaroo once, and that was in like second grade, and then I never did it after that.
I think I took it once, and I forget what grade it was I was in.
I just remember I was very young. Like this was before I got into math contests or anything. I don't even know why I
Oh,
did it, but I did it, and then that was like the only math contest I ever took until like seventh grade.
yeah, I think it was the first like contest I ever took. I'm not sure though.
Oh, I lied. I remember I did mulms in like fifth grade because everyone in my like math class was required to.
I
We
don't even
weren't
remember
required,
if I did both.
but it was like an option, and I was like, why
Hmm.
not? All right.
Well,
Well,
do you want to get started?
yeah, let's get started. William has a special thing for all of us because unfortunately
All right,
Professor
guys.
Lowe, as you can see, is not here. But he
The
sent us a
special
little.
collaborations that we do.
Wait.
Oh, we got a little leak. He sent us a little message to show all of you in his absence.
Hi everyone, I'm Po-Shen, and this time I'm joining you actually from a train because I just spent the weekend at a bunch of math competitions. One is at Andover Academy, and another one was called Math Prize for Girls. It was at MIT. But I actually always want to stop by and say hello because this live solve that we do with Math Kangaroo is one of the special collaborations that we do. Today we're going to be doing the problems from last year's grade 5 and 6 levels. Now, I have to say the highlight of this stream is actually not me. It's the extraordinary people that we have leading it. So you're in for a treat because the stars that are going to be teaching today, they are not only good at math, but they're also wonderful at leading a really interactive class. I want to encourage you throughout this entire session, please make sure to type things into the chat. Hopefully you're doing that now. And you'll find that the responses are like something you're not used to seeing before. But with that, my connection's not that good from this train, so I'm actually going to drop off and hand it back to our stars. Take it from here.
All right, awesome. He just gassed us up. He called us stars. We gotta deliver now.
All right,
All
guys.
right, with that, I'm gonna let William take the first one.
So Aiden fills the rest of the table with the numbers up to 40 following the pattern shown. Which of the following pieces shown could he cut from the table? So it looks like what we have here are numbers 1, 2, 3, 4, 5, 6, 7, 8 in the first row. And then you have 9, 10, 11, 12. So I think to finish the rest of this row, you're just gonna keep going in an increasing order, like 13, 14, 15, 16. Right? I'll actually just write these down. 13, 14, 15, 16. It's really difficult for me to write this down because it's a little small on my screen, but what you can notice is that, all right, let's just write down the next number, 17. We go from, when we go down a column, we go from 1 to 9 to 17. So that means you're going to be increasing by 8 every single time. Same thing for 2 to 10, 3 to 11, 4 to 12, all the way to 8 to 16. And that pattern is going to continue. So the next number in the first column is going to be 25. So we want to find like this block here. They all start with 12, right? So what you want to do, and I think some people already also answers, but like 12, we want to find what this block is equal to, right? So one below 12 is going to be 12 plus 8 equals 20. And then one to the right of it, you're just adding by 1. So it's going to be 21. And then 21 plus 8 for the last number is going to be 29. So our answer is going to be C.
Awesome. I think a lot of people in chat agree with you, which is a good thing. Before we get on to the second problem, real quick, if you ever have any questions about any of the problems, feel free to just type them in chat and we'll answer them. Anyway, moving on to number 2. Which of the following, wait, can you guys see this? Yeah.
I
Which
can
of the
see it.
following shapes cannot be divided into two triangles by a straight line? A, B, C, D, or E? Well, we can kind of just go down the list, right? For number A, I feel like if you notice it, you notice it, or you try lines, like if you think of lines of symmetry, etc. This is a triangle, this is a triangle, so it's not A. For C, like straight lines don't work because you're splitting them into two quadrilaterals, but if we draw a diagonal, okay, Ooh, right there. Triangle, triangle, not C. Same thing. E is kind of like C but nicer. It's like a nicer trapezoid, so we can do the diagonal again, and it'll be a triangle and triangle. B is like same thing like a square. You draw a diagonal, you get a triangle, triangle. And then when we get to D, no matter like what line we draw here, because we want one to be a triangle, the other shape is always going to have like more sides, no matter where you draw it. So it's D.
Okay, so on to, oh, I skipped a lot of questions. Hold on.
Ooh.
Is it question 5? All right.
Yeah. You didn't skip a lot of questions. It's just they pick a few questions. We don't do all the questions. So
Okay. So Ethan climbs from the bottom to the top of the cylindrical tower shown. The steps are all of equal size. 9 steps are visible, but how many steps are not visible? So what I think I want to do is count like the number of steps, like regardless of whether they're visible or not. So what we're gonna have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 9. Is that 21 steps? Arya? I think
steps
I
or
counted 21 steps there. Huh?
okay, 1 second. Ethan climbs from the bottom to the top of a cylindrical tower shown. The steps are of equal size. 9 steps are visible. How many steps are not visible? Oh,
They're
you
a
just
little
count.
small, but like,
Is it 21? 5,
yeah.
6, 7, 8,
I'm
9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21.
Yeah, it looks like Curious Fox agrees with us as well. So we're gonna go with that. 21 steps total, right? And 9 steps are visible, but the steps are just not visible, are just the total amount minus the ones that are visible. So 21 minus 9 is going to yield 12 steps that are not visible. So it's pretty nice that they gave you the number of steps that are actually visible. And the answer is D. All right, next question.
Awesome. Okay. Let me pull it up here. Ooh. Okay. The picture shows a parcel around which 4 tapes labeled M, N, P, and Q are placed. In what order from first to last were the tapes placed? Well, right away I see that P is like we can think about this in terms of layers. P is on the outside. I'm gonna say greater than, okay, because in terms of layers, think of the outmost layer as like the fourth layer. P is greater than M because it's on top of N, and it's greater than N, and it's greater than Q because it goes over Q here, it goes over M here, and then it goes over N2 because M is below N, or N is below M. So P is like the outmost layer. So we can immediately like get rid of option B. And then if we think of the second most layer, we have Q, which is on top of M, which is on top of N. So N is less than M, which is less than, and here we see Q is over M. So Q is here, and then P is greater than this. So they go in like that order. So in terms of first to last, we just do the reverse of this. So we go N, M, Q, P, N, M, Q, P, right there, option D. You just kind of look at the picture, try to figure out what's on top, what's on the bottom. Awesome. Let's go. You got it right.
Next question. The white circle with 3 holes punched in it is placed on top of the clock face. The white circle is turned around its center. Which 3 numbers is it possible to see at the same time? So right now we have numbers 1, 5, 7. If we rotate this circle a little, you're going to get 2, 6, 8, right? You're increasing each number by 1. And then 3, 7, 9, 4, 8, 10, 5, 9, 11, 6, 10, 12. And then once you hit 12, you actually have to loop around. So 12 doesn't go to like 13, it goes to 1. 7, 11, 1, 8, 12, 2, 9, 1, 3. Wait, hold on. Did I like, are any of these the answer choice so far? I don't think so, so let's keep going. So now we have 9, 1, 3, 10, 2, 4, 11, 3, 5, 12, 4, 6. So it looks like this last one, 12, 4, 6, is going to correspond to answer choice C, right? So the only triple that could possibly appear is 4, 6, and 12. And yeah, that appears to be the answer. Answer choice C. Okay, next question.
Awesome. Let's move on to what's the next number? Number 11.
Yep, number 11.
Julia wrote down 3 consecutive 2-digit numbers in ascending order, but instead of digits, she used symbols. What? She wrote 3 consecutive 2-digit numbers in ascending order, but instead of digits, she used symbols. Okay, what number is next? Consecutive, which means we have square star. Oh, okay. So like the star represents digits. Oh, okay, interesting. And then triangle and then heart square. Okay, so since these are consecutive, right? I'm gonna from this, since the tens digit is the same, we can tell that triangle or square is equal to triangle plus 1, and it's also less than or equal to 9. So it's a non-zero digit. Or yeah. And then since what we have here, what it tells us is since the tens digits are different, by adding 1, you basically go up, which means like square. So when you add 1 to diamond, you're going up, and since we're going up by 1, triangle has to be a 0 here, and diamond has to be a 9. But if triangle is a 0, that means square is a 1 from this equation over here. So square is a 1, and this means heart is a 2. So we kind of figured out all the letters. So this is 19, this is 20, this is 21. So the next number would be 22. But then what is 2? 2 is a heart. So it'd be CC. Or heart, just C, not CC. But yeah.
All right, that's a very nice question, actually. Our next question is going to be problem 13. When I look in the mirror, I can see the image of my digital clock standing on the table behind me as shown. What image will I see if I look in the mirror 30 minutes later? Okay. So what we do here is let me actually okay. So think about this. We have I don't really know how to explain this, but okay, so if this is what you see in the if this is what you see in the mirror, actually what you see uh if it was not mirrored, what you would see is one. Wait, hold on. What? Wait, am I messing up somewhere?
I don't think
Would you?
wait, are you sure that's what you see in the mirror? I think that might just be the clock time
No,
because
I don't think that's what you see in the mirror.
it would be because the 5 or whatever would be on like the hours, but can't be 51. And it's not even 51 because it's backwards.
Yeah, I can see that. Like,
I think this is like the normal clock time. That would make more
okay,
sense.
that would make wait. Hold on. I don't think no, this is not normal. This is definitely not normal clock time. No, because like usually the one would be like appear here, right?
Oh, with the one.
Anyway,
Oh.
I'm trying to visualize this. Yeah, I think what happens is what you're actually gonna see is going to be 21:51. Yeah. This is 24-hour time. My bad. I'm just so used to like not 24-hour time. But this is what you're gonna see if you looked at the clock normally instead of in the mirror. And then if you go 30 minutes further, you're gonna get 22, 21. And then if you mirror this again, you're going to get 1, not 2. The 2 flip, which looks like a 5. 1, 5, 5, 5. So your answer is gonna be D. Alright, I was a little confused because I am not very used to like 24-hour time, but here we go.
That's a tricky problem right there. Okay.
Yeah, it is.
Next one. Which 2 tiles should be used to complete the puzzle? Okay, interesting. Well, I I I think kind of just see what you need to fit and then see what works. Right away I see like this shape right here, like over here, because we see this and this little notch fits in really well here, and then that portion over here fits right here, and so does this Mickey Mouse looking thing goes here. So I'm gonna say this piece fits in that crack there, but does that work? Because do I have to have another piece that fits in over here? And it seems like I do because this goes here, and then I get like 3 hexagons right here, and then 2 more here, and then this square thing matches up here, and then this thing goes here. So it's kind of literally just like a jigsaw puzzle. But 2 and 4 seem to fit. 2 goes here, and then 4 goes here.
It looks like
See. That's
really
right.
interesting puzzle,
D.
but yeah, D.
I
I
feel like
think what's so funny about this question is that like this piece looks like it looks too big to actually go in here, but apparently it does. I think it's
I
because
think
of the
the
little
pieces
pegs.
are off scale. There is no way
Yeah.
that actually fits into the picture. Yeah.
Yeah, it does not look like it fits in the picture, but all right. Anyway, next question. Goran, however you pronounce it, has 4 blocks stacked as shown in a single move. He takes some or all of the block from the top of the stack and places them upside down. He wants the blocks to be stacked in this order. What is the smallest number of moves he needs to make to get from this starting position to the correct order? He can take some or all of the blocks from the top of the stack and place them up. Oh, okay. So, uh, let's see. I think what you want to do is first you want to get this purple block on the bottom, right? But what instead what we could do is we can first place this purple block on the top because we take the first 2 blocks and flip them over to get that. Okay. I'll make this block extra long. So this is after step 1. The purple block going to be on the top, and then the other 3 are going to be in the correct order. And then next, you can flip the entire thing over. So now the purple block is going to be on the bottom. And then we have the remaining 3 blocks upside down, right? And finally, we can flip these 3 blocks up. And then you will get the desired position, which is just the increasing order. So our answer is not C. 3 moves, so it's going to be B. And yeah, I think this is a good illustration of what I did. Okay, next question.
Okay, let's see what we have. We're kind of zooming through this. Number 19. Okay. Olivia wants to swap 2 numbers so that the sum of the numbers in the white cells is equal to the sum of the numbers in the gray cells. White cells, I don't see white cells, but I'm gonna assume it's black versus gray in this case. The coloring got changed. Which 2 numbers does she need to swap? Okay, well, I'm gonna start with finding the sum of the gray cells. So sum gray equals 10. This is 10. This is 9, so 19. 19 plus 11 is 30. And the sum of the gray cell, or black, sum black equals 9, 13, 22 plus 8 is 30. Wait, what? 9, 22, 30. They're already equal. Did I
14,
mess up my addition?
Let's check the sum of which two numbers does she need to swap? I don't. Wait, I got this thing. The sum of the numbers. Is this a? Are we getting the right
think-
question? Right.
I think they might have given us this thing after it's swapped. 31.
31.
What? 31.
8, 6, 6, 6. No, I got 30 for both of them.
Yeah, I did. I got 30 as well.
1, 2, 3, 4,
Huh?
5, 6, 7, 6.
Gray is
Gray
28.
is
No, this is not true. What? 11 plus 9 is 20, and then plus 6 plus 4 is 30. Okay, I'm gonna go out on a limb and say they gave us it's 30, they're trolling you. Dude, for real, that's what I'm saying. Stop trolling in chat.
okay. Should we just move on then?
Yeah. They're both equal, so you can't really swap anything. I'm gonna assume they messed up the
Yeah,
daily
just swap
challenge.
2 and 2. That's the answer.
Okay, that's not an option, but we can make our own option.
Okay, so it looks like this is what they're looking for, 1 and 11. You want the, it kind of looks like they did the exact opposite. But, all right, let's move on to the next question then. Anish wants to draw figures in the 6 boxes of the pyramid shown. Each box should contain all of the figures in the 2 boxes directly below it and nothing more. He has drawn the figures in some of the boxes already. Which figures should he draw in the box in the middle of the bottom row? So does that mean that the bottom left and the bottom right are like already complete? I would assume so. All right. So the first of all, this row contains one circle, at least one circle, I should say. This also has at least one square and at least one square. I mean, one circle and one square. And the final box should have 4 circles, right? So let's say if this has one circle, then this circle contributes 1 to this box, and it also contributes 1 to this box. So as of right now, we have 2 circles in each of the middle boxes. And then we don't need any more squares in this middle box because we only need 1 square at the end. And we already got it from here. And for triangles, we need 2 triangles for the top box. There are no triangles here, no triangles here. And so that means we have to put at least 1 triangle here. Right? And that would mean if this box has a triangle, this means that this box will also have a triangle because like, remember, this box is like the sum of these 2 boxes. And same thing for this box. This box will also, wait, did I understand the question wrong? Each box should contain all the figures.
I think you're doing it right.
Which figures should he draw in the box in the middle of the bottom row? Oh wait, I just didn't see this answer for some reason. Okay. So this is the one we're looking for. 1 circle and 1 triangle. Okay. Yeah, there you go. Our next question.
What are we doing this time? 23. Okay, I guess they're just giving us all the odd numbers.
Yeah.
There are 2 machines. Machine R rotates the paper 90 degrees clockwise. Machine S stamps the paper with a clove looking thing. Clove?
Well,
Anyway, in which order were the machines used to create the image shown? Okay. Well, right away I see that the square is in the corner, which means it rotated 3 times. So there's like 3 R's, and then we have to get the stamp. So there's 3 R's and 1 S, and there's 4 machines. So those are all my like machine. Those are all the operations I've done. Now I need to figure out the order, and the way I figure out the order is to notice like how the clove is like placed. The clove is upside down, which means if this is how it usually looks, like it gets stamped normally, it had to have two R's after it to like rotate first like sideways, and then it went and then down, which is what its position is right now. So we have like an R and then an S and then an S.
But
But we also, one second, but also notice that, whoa, okay, my bad. But also notice that like the square, if you rotate twice, was here. So we have like an R, wait. Oh, SRR. Okay, it goes SRR, not RSS. And then notice that this, like, after these two rotates, there was a square up here, so the R is here. But yeah, because like first you go from here to here, then you have a square here, and then you stamp it, you get your little symbol, and then you get your symbol, and then you get a square here, and then you have the symbol upside down, like facing that way, and then the square is down here, which is your final position.
yeah, I think if you think about the club facing the right side up or like going upwards, then the little square is going to be on the top left corner, which means you have to rotate it once and then you stamp it and then you rotate it two more times.
Yeah.
And yeah, it's RSRR. Answer choice B. All right. Question 25. On a table, there is a tower made of blocks numbered from 1 to 50. Emma builds a new tower in the following way. She takes two blocks from the top of the original tower and puts them on the table as the base of the new tower. She continues by taking the two blocks from the remainder of the original tower and putting them on the top of the new tower, seen in the new diagram. Which of the following pairs of number are on adjacent blocks in the new tower? Okay, so I think this diagram will explain it better than what I just said. So you're gonna have a bunch of blocks. One is on the bottom, 50 is on the top. And then, so what you're going to have is 49, 50, 47, 48, and then all the way to 1, 2. You're taking two blocks at a time and putting them on the bottom. Okay, which of the following pairs of numbers are adjacent blocks? So what are the adjacent? We're going to have like, let's just write some out a little to explain. 40, 47, 48, 45, 46, 43, 44. So it looks like what's happening is you have a number, you add 1 to it, and then you subtract 3, and then you add 1, and then you subtract 3. So it looks like it looks like a sequence such that when you have an odd number, you add 1 to it, and when you have an even number, you subtract 3 from it. So let's look at our answer choices. 29 to 28, because like 28 minus 3 is 25, and 29 plus 1 is 30. So it's not going to be answer choice A. If you have an odd number, 35 again, you will end up with 36. And you also can't go from 34 to 35 either, because 34 minus 3 is equal to 31. 29, to get from the number after 29 is going to be 30. That's not right. The number after 26 is 23, so no. All right. And then 31, the number after 31, since 31 is odd, is going to be 32. Same thing for 33. 33 is odd, so number after 33 is 34, so no. And then the last one, 27 is odd, so it goes from 27 to 28, which is not right. But since 30 is even, you go from 30 to 27 in our sequence. So our answer is going to be E. So in summary, I just wrote this tower out as a sequence of numbers with like this little rule. If it's odd, you add 1. If it's even, you subtract 3. And then you go through all of the answer choices and you'll get that E is the only one that works. Okay, so next question.
Let me pull it up. Okay, number 27. In a secondhand store, 2 hats are sold for the same price as 5 skirts. 3 skirts are sold for the same price as 8 t-shirts, and 2 t-shirts are sold for the same price as 3 caps. Which of the following is the most valuable? Well, I'm just gonna since we're giving like 3 equations, we can just solve for all of them in terms of one and then figure out the relative value. So I'm gonna label them like H, S, and H, S, and T. I'll label the variables as what one of them costs. So 2H is equal to 5S, or hats and skirts, and then 2T equals 3C. Wait. Oh, and then we have 3S equals 8T. Is that it? 2 hats are sold for the same price as 5 skirts. 3 skirts are sold for the same price as 8 t-shirts, and then 2 t-shirts are sold for the same price as 3 caps. Okay, I'm gonna solve for everything in terms of, let's just say, H, right? So, or actually in terms of S. So we have H is equal to 5 caps S. Okay, let's keep that down here. And then we have T, or we'll do the bottom one first. We're gonna have 3/8 S is equal to T. And then for here, we can substitute in our value for T. So we have 2 times 3/8 S equals 3C. So we can cancel the 3's and then the 4 here. So we have 1/4 S equals C. So C equals 1/4 S. And then obviously S equals S. So now what we have to do is figure out, in terms of C, which one of these options has the highest value. And I mean, if you wanted, sometimes if the numbers are nice, a nice trick would just be to let C be a value. You could just let C be $1, or I mean S in this case, you could just let S be $1 or something. But actually, let's do that. Why not? So since the price is relative, it doesn't really matter what I label S as. So to get rid of all the fractions, I'm gonna say S is 8. So now my new price for H is, what is it? H is 20, S is 8, T is 3, and C is 2. And now we just figure out what all of these options are. A hat plus 5 skirts is 8 times 5 plus 20, which is 60. A hat plus 3 skirts plus a cap is going to be 20 plus 24 plus 2. 20 plus 24 is 44, 46. 8 skirts plus 6 t-shirts is going to be 18 plus 8 times 8, which is 64. So this is going to be 82. So 82 over here. 37 caps is going to be 37 times 2, because each cap is $2. So we get 74. So far number C is winning. And let's see if the last one wins. We have 3 skirts, which is going to be 24, 3 times 8, plus 3 caps, which is going to be 3 times 2, which is 6, which is 30. So our most expensive one is the $82 one, just C. And note that since all of the prices are in terms of S, that's why we could just let S equals 8, because as the price of S changes, all the other ones change accordingly, in conjunction with the rules we had. So we're not really changing anything. But yeah, C is the most valuable one. Oh, you're muted. Yeah, we can't hear you. Or at least I can't hear you.
Okay.
Yeah.
Which of
You're
the
good now.
following 4 shapes? You can hear me now?
Yeah.
Okay. Which of the following 4 shapes has the greatest area? We have a W, a diamond, and the crown, and lightning. Okay, anyway. So what we want to do here is, let's go over each of them, each of the areas. Let's say this segment is 1 unit long, okay? So if we divide this W into 4 unit squares, you can see that the thing on the bottom left is an isosceles triangle that has an area of 1/2. It's half the area of this square. And the same thing goes for the bottom right triangle. So far the W is 1/2 plus 1/2. And then on the top, this little thing is also 1/2 the area of the triangle because remember, area of a triangle is at 1/2 times base times height. Its base is 1 and its height is 1. So you're gonna have another 1/2. And then you're gonna have another 1/2. So this is gonna have an area of 2. And then for the diamond, it's pretty much the same thing. You're gonna have this little right triangle, and then you're gonna have 4 of them. So 1/2 times 4 is going to equal 2. And then the crown is like it's not as nice because you have like this little gap in here. Let me try to highlight it with a better color than yellow. I'll use red. We have this little gap. But say this gap doesn't exist, then we're gonna have, if this gap didn't exist, we would have 2 of these things. Or let's just say we're gonna have 4 like taller right triangles. And each tall right triangle is going to have an area of, okay, so it's gonna have a base of 1/2 and a height of 2. So it's gonna have an area of 1/2. So the thing, if there were no gaps, the area would be 2, but there is gaps, and it actually makes the area bigger, as you can tell from the diagram. So the crown is some area that's greater than 2. And lightning, if we divide it into 4 quadrants again, you'll see the top left has 1/2, top right has 1/2, bottom left has 1/2, bottom right has 1/2. So this is 2. So even though we don't know the actual area of the crown, we know that it has a larger area than the other ones. It does not have the same area. It's greater than 2. So the answer to our last question is going to be C. And I think that's it. Are there
Yeah, I
any
think
questions
that's
that
it.
you want us to go over again?
Oh.
Sorry, you want to say something?
No, I was just gonna say that's the end. But yeah, I was also gonna say if you have any questions you want us to go over again.
Okay.
Like that. Or if you have if you remember any questions from the contest that we didn't cover, have them in chat and we can go over those too.
Yeah, that works as well. Hopefully we interpret the question correctly. And yeah, as Curious Fox stated, you can rearrange the lightning into a W. It will save you some work
You can rearrange
for the
lightning
last
into the W.
question.
Oh, that is true. I didn't notice that.
Yeah, I wish they gave us like actually if they gave us the evens, I think we'd run out of time.
Why? Oh,
Yeah. We'd go a little over time. What was your favorite question out of here?
my favorite question. You know hold on, I'll pull it out. Let me look through them. I forget. There was one question I was like, oh, that's a nice question. It was at the beginning though. It wasn't that hard. It wasn't like particularly hard or anything, but it was
Yeah, I liked the easier questions more.
um where is it? I think the clock one had I like this one, the number one with the symbols. That was
Yeah, I like this one.
yeah,
This one was my favorite too.
yeah. I like it's like
It's
cool.
like
It's a cool
simple,
idea. Yeah.
it's like simple, but it's a really unique question.
Yeah, I like the idea. It's nice.
Yeah. Because it was easy, but like a cool type of easy. I don't know.
Yeah. I haven't seen a
It's
question.
something, it's like a method you don't see much, but you can think about pretty easily. What other
Those are
questions were pretty nice?
um
Yeah,
I like these
the
questions.
clock one is pretty good too. Because you have to
No,
like visualize
I can't
like
visualize though. I actually I'm so bad at visualizing.
I think what you want to do is if you have like a 12, you have like this 1, 2, 1, 5, right? So let's
Because
say
yeah, I forgot
this,
that the digits themselves are also getting reversed in the mirror. Like I didn't think about that. That's why I was
so if you
confused.
have like this mirror, and then you have like a 1, 2, 1, 5 here, and
Yeah, it
then
becomes a 2 1 5
I think
1.
you can like project or something. Like um you're gonna end up with a 2, 1, 5, 1. You can like I don't know how to explain it. You just have to like think of
It's because it's
you just have to
backwards.
visualize it.
It's like
Yeah.
backwards. Like it goes hours, hours, minutes, minutes, and then when you're looking at it in the mirror, it goes minutes, minutes, hours, hours, but each of the digits is getting flipped as well because you're looking at it from the opposite side. So then the 5 becomes a 2, but it's on the left side. The 1 is the 1, but it's on the left side. The 2 becomes a 5, but it's now the third digit, and the 1 becomes a 1, but it's the fourth digit.
Yeah, I think what you could do is like say this is you, right? You're looking at this way, but like if you pretend that this was a window instead, you were looking from outside, then you would see that this is 2, 1, 5, 1.
Yes, that works as well. That works as well. Yeah.
Yeah. I'm trying to justify why like I saw 2, 1, 5, 1, but I don't know how to.
I think, wait.
No, it's definitely 2, 1, 5, 1, especially since the answer like we got the
Well, no, it
right
is
answer.
right. It makes sense too in my head because I see it now. Like,
Yeah.
but
Yeah, I think if you just like
you just
take
reverse the digits.
this 2D
Like,
thing and you can like yeah. I guess you could just say you can reverse the
the idea is you just like reflect it over that way, and then that's the new like time.
Mhm.
And then when you reflect it over this way, like every everything flips over. Like the 5 becomes a 2, the 1 becomes a 1, and then it's a 5 and a 1.
Yeah. I don't know, like maybe I just don't know enough mirrors, but
Wait, I think okay, hold on. This is legit, right? I think this is legit. One, okay, so I have 1 2 1. Wait, can you see my screen?
yeah.
Okay, like when you're looking at it from the other perspective, it's like you're just reflecting this over this line. Like, can you agree with that? I mean, to come up with that, because like when you're looking at a mirror, it just reflects it, right?
Yeah. Okay.
So instead of reflecting it like this, just extend the reflection over like the plane, if that makes sense. So now you're reflecting
Yeah,
it
I
over
think
this line. So then like this line is gonna come over here. This line is gonna reflect closer here. This line is gonna be here. This line is gonna be further away, and then this line is gonna be here. So it becomes a 2 on the furthest side. This becomes a 1. And then this line goes here, 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 and this line goes here.
I think that works. All right.
Yeah.
Oh, what other like good questions are there? Or
The
at
puzzle
least
question was
there's
nice.
this
I
really
think the
funny
puzzle
one.
question. Yeah.
There's no way that actually fits in there. It
It
might be
makes
because of the little rectangles that just like wait, no, it's not because of the rectangles.
I think maybe it's just like an optical illusion. Like it seems like it
Yeah,
doesn't fit, but it
it
does.
totally looks like it does not fit in there, but it does.
I think it's hard
Now
to
that
see
I
the like I think it's hard to see the consecutive like you have to visualize it like with the squares. Like visualizing the octagons is kind of hard.
uh, I
Like
mean the squares probably fit in there.
this is where when I was looking at that question like um visualizing like what's going on here is like kind of wacky. Like I like had to visualize it through like these portions at the end because it's like easier to see
Yeah.
where the squares fit. But the middle like area is like hard to see what fits there.
I think what I did was like you could pretend that this is like a coordinate, right? Let's say that this is like 0, 0 or whatever. You go right one, you go up one. So you have like a point here, 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 a point here. And that corresponds to this to shape number 4, right?
Okay, yeah, that's legit. Yeah, that's
And then you can also mark some points here. And that should give you 2 point shape 2.
yeah.
Oh yeah, this one's also an interesting question.
The block one.
Yeah.
I don't really know how to like why is three the smallest? I mean, well, just
I mean, you
beginning.
can get 3,
Yeah.
but like, can you show why 2 is not the smallest? I mean, the thing is, you can't get
need
the purple block down in one step.
Yeah, you need at least two steps to get the purple block down there.
Yeah.
And then well, you also need one more step to take the orange block away from the purple block. Wait, no, you don't. Yeah, you do.
I mean, like, there's
Yeah.
only one way to get the purple block to the bottom in 2 steps, right? And that doesn't
Uh,
solve the game. So that means we need one more move. So that's why 2 doesn't work and 3 does.
is there only one way? Oh, I guess there is. Yeah.
I think you're safe to assume that, like,
They were trolling me in chat, bro. Like,
oh, this one is like,
wait, does anyone
yeah,
have any questions? Did anyone?
maybe I can look this up online actually.
Um. Okay, no questions.
Uh, doesn't seem like there are any more questions. Wait, can you check like the viewer count right now?
The viewer count. Well, it's just on the Zoom. There's 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh,
And then there's 3 on YouTube, or there were 3 on YouTube. I don't
okay,
know if
okay.
they're why.
I guess Zoom's a little more popular than I'm not in the Zoom. I'm not in the YouTube either.
I don't think you're not supposed to be in the Zoom.
Okay. Wait, then how can you see the how many people are in there?
It's an our Zoom call.
What? Wait.
It's not. Yeah, all the live streams are
Oh,
on
wait.
YouTube. All the live streams are on YouTube. Feel free to go check them out whenever you want to. Like if you forget to sign up for the live solve or whatever. The only problem is YouTube chat doesn't interact with us, so you can't like your messages won't pop up on screen and stuff, so it won't be as fun. But worst case scenario, always check out YouTube, and you can see other live streams. Like every live stream we've ever done is posted on there, so you can check out like all the other Math Kangaroo live solves, like in case you're preparing for the contest or something, or you just want to check them out. Poe also used to do this thing called like Ask Math Anything, which is kind of an interesting thing. This was during COVID. He used to like do live solves where you could ask him anything and he'd try to answer. Still have like 5 minutes left. Have I done every? No, 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 no. There, like, I've only done like maybe 4 or something, but the live solves are done by like a bunch of different people.
Yeah, it would be kind of scary if I had to do every single one of them.
That would be a lot of work because there are a lot of live solves
Yeah.
going on. I'd say the most fun lifestyle I've ever done was the OMMC one. That was pretty fun.
Hmm.
It had the best problems so far out of all the lifestyles.
Okay. Number 29 is not a bad question either.
Um, I
Yeah,
don't like number 29. I don't, well,
really? It's like
it's just like it's very normal.
oh, I
I
didn't
don't
find the crown very normal.
the crown.
Yeah,
Wait, why?
you just have to say it's like it had an area greater than 2, right?
You can find the area by subtracting the. Well, you can also assume that this is like 3/4 or like 1 + 3/4.
Okay.
Like that's probably what they meant. Like, but yeah, I mean, it is greater than 2. You can also go that way.
I mean, I can't see how you can get like, maybe it is 3/4.
Well, actually, it actually looks a little bigger than. Well, yeah, it looks like 3/4. Like to be honest, like I think I'd feel safe
Which
making
is,
that assumption, but
it doesn't really matter at the end.
I think my criteria for good problems is like something I've never seen before.
Yeah. Oh, well, like I think I've seen like the digits one before, but for some reason I still liked it.
You've seen something with the shapes with digits? I don't think I've ever seen them.
I don't know. I just feel like I've seen something like that before,
Well,
but
actually, I've seen questions that are like letters representing digits, but I just like the way this is phrased. It's clean. It's like nice. It's a
mm.
cute problem.
Yeah, I do like the problem itself too.
I hate those problems that are like multiply ABC by BAC and then like equal to DACC. What is the D? Have you ever done those problems?
No, those are the worst. I don't know.
Yeah,
Is
yeah.
there like
Those
supposed to be a good, is there like a good way to solve them, or do you just have to
no,
try
you
everything?
just well, like you can usually like find bounds on what the letters are based on how the multiplication
Yeah, but
goes.
like that's the
But
only
I feel like
optimization you can do.
there's always a significant amount of casework that goes into it.
Yeah.
Oh, I think the tower one is was pretty nice.
Yeah, we were talking about that earlier. Wait, this one?
Yeah.
There are a lot of tower ones. Or
Well,
there are
yeah,
just two. There's a tower one on your screen right now.
there is.
I mean, do you think that counts as a tower? Like the one with
Oh,
the 4 blocks.
yeah, okay, that I guess that counts as the tower. I meant I think this is nice. At least the way you solved it is pretty nice.
Yes.
I did it a little differently.
Wait, how did you do it?
Well, it was the same observation really, but it was just like, well, it was actually the exact same. I just was
Oh.
like, it goes like even number, you minus one below it, add three above it. That's what I.
Hmm. Oh, so you start from the top, I guess.
Yeah, I
It
looked at
doesn't
the
really
picture on the
matter
screen
then.
and I was like, oh, so it goes 2K and then 2K minus one, and that's how the blocks go. And then, yeah,
Hmm.
but the way I did
Are
it
there
was
any
like,
less
no, um,
curious boxes? Like, can we do another question?
can we do
I
another question?
mean, we did
What
all of
question?
them, but
Um, can we do another question? Do you have a quick math problem?
uh,
Do you have a
I'll
quick math?
show you. All right. This is not really a math problem, but
Oh, I already know that problem. I don't want to do that. Can we stop? Can we stop?
I spent like two
I'm good
hours
with
on
my
that.
anti. I'm good with my anti.
I spent like at least 45 minutes on that thing.
Did you? Okay. Well,
I don't know.
I spent a solid 10 minutes, looked at the answer, and then proceeded to be mad that I didn't solve
Oh,
that.
okay. No, I was so bad. I'm so bad.
No, because listen, I think I was doing it in a unit where it was like specifically stated, if you don't solve this like as you look at it, just don't try to solve it because you're not going to.
Oh,
I don't
one of
think
my friends just showed me like he just showed me a bunch of questions that like you're gonna be so mad when you see the answer. And one of
like
them was
called
just like,
anti problems.
oh, that might be it. Because like
If you ever do
I don't know.
arts,
A curious
there's a
fox
whole
is
unit
wondering what it is.
about anti-problems. Oh, okay. Actually, try to solve it. I'll stay here for like 2 more minutes, and then
If you can't solve it, that's okay because a lot of people took a really long time to solve it.
yeah, this is like ironically, this is a very hard problem. Oh,
They don't even know the problem though.
the problem is split it into four congruent quadrilaterals.
Four?
Yeah.
Oh, I was just like split it into three equal shapes.
Oh, three
Yeah,
equal
I think it's quadrilaterals.
not quadrilaterals, four congruent shapes, four congruent shapes.
Yeah, three or four both work.
Oh, there's actually two solutions. There's like another solution, which is like pretty, it's a pretty nice. It's like the second solution is like much harder to find, but
Oh, really?
it's not like a dumb splitting. Like it's there's actually like a
Oh,
nice
I see it.
uh
I see the second solution for four.
yeah, it's four. That's what I remember four.
I think there's only one solution for three though. If it's three congruent
Oh,
shapes.
oh, I lied. Now that I see it, I don't think it's any smarter than the previous one. It's the same. It's literally the same thing.
Yeah. I feel like
Why
I
does
feel like I have a higher chance for me.
why does x
Wait.
plus y equal what does x plus y equal if x equals 9 times 8 and y equals 8 times 2? 88. I don't know if you want to spoil this problem.
It's a really funny question.
It is funny. I kind of feel bad if we tell you the answer right now.
Yeah. Oh, it's so funny.
Do you know the source? We can leave them with the source so they can
I
look it
have
up
no idea.
themselves.
I think one of my friends was just like one
I
of
know
my
it's
friends drew the question and then like told people he made people solve it and then they didn't solve it for a long time. They found the solution and they got mad.
I think it's from Math Prize for Girls. I don't remember what year though. Uh okay, let's see if I can find this. It will take me like I can find this pretty quick. Oh, okay. I found it. Math prize for girl. Wait, that's the wrong one. But history when it's from 2017. Problems.
You're talking about like this shape one.
Yeah, the shape one. Wait, is it from the Olympiad? It would be really funny if this is on the Olympiad. Okay, I don't think it's on. Okay, thank God. That would have. Okay, that would
Or
be.
they just gave it to a bunch of testers to solve.
That would be like a really funny.
That'd be like the worst question ever, but like that would be the question that everyone
Wait, there was a problem that's the same as like the Armel number 8 this year on this test. What the heck?
What was that? Was that like the geo?
Yeah, it was the GA with the research list, but the same configuration as part of Math Prize 2017. I just stumbled upon it, which is interesting. It's literally the same problem.
I'm
Armel.
still mad at Armel number 9.
Wait, why? What happened?
Uh, I got trolled by it really badly.
Did you like find the perimeter, some of the perimeters?
I did like some really weird thing. I forgot what it was.
Um,
And I ended up getting it wrong.
okay. I think I got Armel 9 wrong last year.
No, because it's funny because like our school sent 3 teams and so like one team was better than like let's just say team 1 was better than team 2 and team 2 was better than team 3, but like everyone on team 3 got it correct and only half the people on team 1 got it correct.
I think this is similar to what happened at
Because I think people just thought it was like too easy, but it turns out it was the actual solution was that
I
easy.
think wait, number 9 is usually just easy, right?
Number 9 is usually easy, but like number 7 and 5 are like terrible if I remember.
Number 5 was
Mm,
much harder than usual.
Yeah. Then it's just number 9 is like number 9 was really easy, but then everyone's like
I think they like switched. Like I think number 6 was easier than number 5, and I think number 4. Well, number 6 was easier than number
I'm
5,
trying to
but I
recall
think
all the questions.
7 and 8 was a hard pair. 7 and 8 was a hard pair for sure. All right. No one wants to leave. Indeed. Okay, easy one. 25 plus 2 equals x. 6x. Oh, x plus y. X equal y. Whoa, 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 whoa. Minus 27. Bam.
Oh, that's a pretty neat question actually.
Interesting. Um, Unfortunately, I have to leave now. I think you should spoil the problem. They should know.
Really?
'Cause I can't find the
Have they
source.
been trying the problem?
I don't think they have, but it's funny. Hopefully they forget.
Oh.
I don't think it's harmful to their uh, math development if we spoil this
Especially
problem.
since they only didn't try it for that long. I don't think they've been working on it either.
Okay, well, keep this problem in mind. Think about it. One day you'll see it again if you keep doing math.
Yes. One day you'll
And
find the solution and be mad.
yeah, we won't give you that anger right now.
Okay.
Bye, Curious Fox.
Bye. Yeah, I'm gonna have to go now too.
Oh, we should probably wait for Debbie to close it.
Oh, that's true.
Bye, everyone.
Bye.
Oh, Isha says, what's the problem? The problem is split the shape that William has on
Oh,
his screen into four congruent shapes. Four congruent shapes. That shape, which you see, like the lines are parallel and it's like a rectangle with a little peak thing, but split it into four congruent shapes.